I want to show you some of the features for the DESMOS calculator and some of the things that you can do. First of all, if you are given a table of values, and I found a table that compares hours of sleep and GPA, and I'm going to use this table of values to show you how to do some lines of best fit and different things with the DESMOS calculator. So obviously we're at desmos.com, we're in the graphing calculator. First thing I want to do is put this table of values into the calculator. Over here, if you press the plus key and go to table, notice please that the x value is not just x, it's actually an x sub 1, and the y value is a y sub 1. Keep that in mind for future reference whenever we're trying to do the line of best fit. So my x values I'm going to enter are hours of sleep. So I have 7.2, 4.3, 5.5, 5.1, 6.2, 7.2, and 7.0. These are my hours of sleep, and this is the GPA. 3.5, 2.1, 2.6, 2.5, 3.0, 3.6, 3.4. Okay, so if you notice over here, we have plotted those. It's in purple. You could take those plots off if you want to, but you can move the graph, you can blow it up, shrink it, focus on a specific part. So I'm going to look here. I like this picture. So now I would like to get the equation of a line that would go through those points. And if you notice, if I click on them, it'll actually give me those points. I'm going to turn those back off. This is the important part to remember, and this is probably where you want to take some notes. To get a line of best fit, normally we follow y equals mx plus b. Remember where I told you this is not just a 1, it's a y, or excuse me, it's not just a y, it's a y sub 1 and an x sub 1. So this is what you key in for the calculator to give you a line of best fit. You start with a y, and then you just enter the number 1, and it automatically turns it to a sub 1. Now, instead of an equal sign, you're going to enter the value of tilde. Tilde is a shift and the button to the left of the 1. So it looks like that. Again, it's beside of the 1 to the left, and you have to press shift. That's a tilde, because this is an approximation. This is not an exact. So that represents our y equals. Now we go ahead and type in the m. Notice we start getting things already. Then x, we can't just use x because it's a 1. So type in the 1, it automatically makes it a subscript, plus b. So if you notice here, now it has created the line going through as many of the points as it can through the center. This is your line of best fit. So this is your M and this is your B. So I'm just going to take a note here. If I'm going to round that off, I'm going to say y equals, for my M, I'm going to use 0.5, then x, I rounded it off. The B is a negative, so it's going to be a minus 0.08. So that would be my equation. Y equals 0.5x, that's my M, minus, because the B is a negative, 0.08. So we'll use that again in a minute. I want to notice some things first off here, and this will help you when you get to statistics. First of all, let's focus on the R for a second. R equals 0.9964. Again, you might want to take a note of this. R is the correlation coefficient. Correlation coefficient is the R value. Correlation coefficient tells you, first of all, if it is going uphill or downhill. If it's positive, it's going uphill. If it's negative, it's going downhill. But the most important thing about correlation coefficient is how close is that number to the whole number 1. The closer that number is to 1, the stronger the correlation is between the line of best fit and the data points. If you notice here, if you look at it, the data points are super, super, super close to that line of best fit. So that would be a strong correlation, and your correlation coefficient would be 0.9964, which essentially would round to the whole number 1. If the dots were more spread out along this line going through the middle, you might have a 0.8 something or a 0.7 something, and that would be a lesser of the strength would be less for the correlation coefficient. The other thing that you're going to be looking at, and when you get into statistics, is residuals. Residuals is basically plotting how far away are these points from the actual line of best fit. And in order to plot them, it plots them down here on this line. So notice it says residuals. If you click plot, it has now taken those points and plotted them down here. This means, this goes with this point, and if you notice, it's ever so slightly above the x-axis. That shows that it's very close, but a little bit above. This one is a little bit above. This point is a little bit below, so they put it below the x-axis. This one is almost exactly on it. This one goes with this one, and these two go here. Now, if you're trying to determine which one was the closest, and this one's kind of hard because they're all so close, they've plotted these points and told you how far away they are. So we've got a 0.022 to 9.07. So that one's probably the farthest away. 0.029, 0.21, 0.21. So I think these 2 points, 0.021, yes. This one and this one are the smallest number. The negative just tells you that it's below the line. That's really not important. This one, 0.214, 0.219. This point, 6, 2, and 3. So I'm going to try to find it over here. Right there it is. And obviously that makes sense. That one is the closest to the line of best fit. It's the most accurate on the line. Which one is the farthest away? It's the one that has the biggest residual value. 0.07, 0.077 looks like this one, the 7.2. And right there it is. And you can tell that it's the farthest above the line. So if they wanted to know which one was the closest, you would pick this point. Which one is the farthest away from the line of best fit or has the highest residual value? It would be this point. So you look at these numbers to determine how close are these points to the line of best fit. So the last thing I'm going to do is I'm going to clear this out, and I'm going to do it a little different, in the opposite direction, I guess. I'm going to type in that equation that we had. Minus 0.08. Now notice I did use the plain y and the plain x here. You only have to use the x1 and y1 when you're going from the table to the equation. But remember, I wrote down that equation, the rounded off value, and this is my line of best fit equation. Now here's the cool thing. Let's say I would like to know what would be the expected GPA for this line, based off of this line of best fit, if someone got 6.5 hours, 6.5 hours. 6.5 was not on the graph, was not in the table. So I'm trying to find a value that's not in the table. So I can go inside of this. I'm going to click the gear, and I'm going to change this equation now into a table. So here's the cool thing. It says basically if you get 1 hour of sleep, this would be your expected GPA, 2 hours and so forth. And I can just enter in values. 5 hours would be a 2.42. 6 hours even, a 2.92. 6.5 is a 3.17. And maybe if you got a whole 8 hours, that's your 3.92. So you could find those values that were not in the table by putting the equation of the line of best fit into the calculator, clicking the gear, changing it to a table, and then entering in your X value that you're trying to investigate to determine the Y value. So all these things are super important and super helpful whenever you're doing any type of statistics, scatter plots, line of best fit, interpreting data, residuals, and correlation coefficients.